Okay, we're asked to construct a graph with factor 5 halves, then we're asked to construct a graph with factor 3 halves, where the point 1, 1 is out here, pretty close to the upper right-hand corner of our graph window. So I'm going to put 1, 1 out here, and I'm actually going to say, okay, that's going to be 1. And I'm going to do this, and that's going to be 1. That doesn't really matter, but if I do that, then I can cut this in half, I can cut this in half, cut this in half, and so forth. I'm not going to do all that. But now, if I'm doing the 5 halves, or the 5 halves graphs, that's the first one, then when I go from here to here, my x or my y value should increase by a factor of 5 halves. That's a factor of 2.5. Now, what does that mean? That means if I go from here back to here, my y factor is going to be 2/5. So 2/5 is 4/10. You should be able to do that almost instantly. So that's going to be about here, and I'm going to say that for the 5 halves graph, I ought to have a point here. That's about 2.5 times this. 5 halves, 1, 2, and then a third would be here, and the half. That looks pretty good. So it's going to be somewhere around there. Now, you want to think about whether this graph actually then goes through the point 0, 0. You want to reason that out. If it does, and you can't just assume that it does, but if you can reason out that it does, then it appears that the graph of this function should look something like this. Now the graph of the function with the 3 halves factor, by contrast, is going to look something like this. And I'm just going to kind of slop this down because we've already done a 3 halves graph several times. We kind of know what it looks like. Okay, so this is a graph for factor 5 halves. This is a graph for factor 3 halves. Now we're asked to do a number of things. We're asked to estimate f of 1/4, f of 1/2, f of 3/4 for the graph of the, and where did I put, okay, looking for the wrong color. Okay, so this would be our f of x graph according to the instructions. And this graph we're going to call g of x. Factor 3 halves, both power functions. So power functions through the point 1, 1. Okay, so we're asked to make some estimates now. We estimate f of 1/4, f of 1/2, f of 3/4. We estimate g of 1/2, g of 1/4, g of 3/4. I'm not going to do those. I'm not going to set up the scale. I leave that to you. Geometrically, though, what are we looking at? Okay, eventually I ask you for things like the values of f of 1/4, divided by g of 1/4. Okay, well, f of 1/4 turns out would be, here's 1/4, would be about this, g of 1/4 would be about this. So what's this divided by this? Well, if you consider this to be 100%, what percent is this? Looks to me to be about 30%, which would be maybe about 0.3. Maybe it's closer to 0.2. Maybe you can refine it a little better. What about f of 1/2 over g of 1/2? Well, here's f of 1/2. Here's g of 1/2. You could say, okay, here we come over here, and for 1/2 we come over here, and it looks like maybe about 0.5, and this looks like about half of that, so maybe that's 0.5. Now I want you to come up with more precise estimates than I've got. I want you to eyeball it really carefully. And do it without calculating. Do it by eyeballing it. Okay, what about here? Well, here would be my two values. I come over here, and I come over here, and that one's actually a little low, but this one looks to be maybe 6/10, maybe 7/10. And that would be f of 3/4 over g of 3/4. Is that 6/10? Okay, I drew that very carelessly, pretty sloppily. So, and we really don't know that the g of x graph has quite the right shape anyway. But on your graph, you should come up with pretty good estimates, and you really ought to be able to estimate these ratios, with reasonable precision. With a little care, you should be able to estimate them to the nearest tenth. Then we ask, what's the trend? So you can answer questions about what's the trend. What's going to happen if these graphs go out beyond x equals 1? I'm going to leave those questions for you to consider.